All right, so we are going to talk about finding side lengths. Remember that we're gonna have these three things. We're gonna have sine of whatever of x. We're gonna usually use theta, of course. So let's actually change that. So from now on, this is a theta, and we're typically going to use theta to show angles. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse, sorry. And cosine of theta is that. And tangent of theta is opposite over adjacent. So let's start by looking at this. Around the nearest thousandth. Okay, so in the second one, just let's like quickly just talk about what we would use. We would use tangent here, right? Because we have opposite and adjacent. So this would be opposite of it. This would be adjacent. That means like I always think of opposite like as if it's like a lake. You know, it's an oddly shaped lake and you're swimming across it. So you don't want to be on this leg or on this leg because those are both creating the 75-degree angle, right? You want to go all the way across to the other side of the lake. That's how I think of it. So that's where opposite is. Adjacent is touching you, or it's one of the, sides that makes the angle, but it's not the hypotenuse. Okay, let's try another one. Let's do, actually, let's do number 2 just because we can, and because it's set up a tiny bit different than the last one. So you'll see that the x is on the bottom this time, which actually in some ways is easier. So tangent of 75 is what we need. So we'll just hit tan 75, enter. Oh, it gave us an actual root 3 plus 2. 3 plus 2. Interesting. I should be able to get that from fraction to decimal here, I think. Oops. Still there. So it has something to do with like exact. So see this? This is how many decimal places you can get. I think this will give us 3 decimal places. I could be wrong, but if I remember correctly, that's what that does. Nope, didn't seem to help. Okay, so we'll figure it out. I don't know on this calculator how to get out of that, but let's just try it here. You probably won't have that trouble with yours. There we go. So 3.73, we're still in degrees here. 3.732. So it's going to be 21 times 3.732 equals x. So x will equal, so just take that and multiply it by 21 times 21, 78.373. 78.373. Okay, so hopefully not a big deal for you. Let us keep on going. 1, 2, 3, 4, 5. Okay, so this is pretty good. I think that you'll be pretty much okay with these. Let's talk about what we had at least used to set up this one. So this one is going to be, here's opposite, here's adjacent, here's hypotenuse. Make sure you talk to somebody if that's not good with you. It should be good with you. Oops, sorry, that's not opposite. That's hypotenuse, that's adjacent, and that's opposite. It's all relative to where the angle that they're talking about is, so we're basing it our opposite off of this angle and going opposite. Hypotenuse is always pointed to by the right angle. I try to make it into like a little arrow, points to the hypotenuse. So for this we would have cosine of 64 equals 3 over x. And again, you can multiply by the x to get it out of there. and then you'll divide by whatever this decimal comes out to, because you'll have that decimal times x. Okay, should be a review. Okay, so opposite and hypotenuse. So sine of 18 degrees, make sure you're in the degrees mode, is opposite over hypotenuse. So we'll multiply by x, and we'll get whatever sine of 18 is. Let's just do it. So sine of 18, 0.309. So 0.309x equals 25. So 25 divided by that. So it's going to be 25 divided by, and ideally we'll use second answer here. It'll give us the most accurate. Whoops, I did it twice on accident. 80.902. So x is 80.902. Does that make sense? I mean, looks like it does look like it would be about like 3 times this 25. I don't know if they draw it to scale. Okay, so all of that to say, you are also going to be able to use the following. If you take the inverse sine of both sides, which is written sine to the -1, it's not an exponent of -1, by the way. You take the inverse sine of both sides, sine to the -1, then you'll have the following. Theta is equal to sine to the -1 of whatever ratio there is. So if you think about it, sine of an angle gives a ratio, and arc sine or inverse sine of a ratio, so you'll put the ratio into your calculator, that'll give you an angle. Okay, so again, this will be cosine to the -1, inverse cosine, or arc cosine, I like to call it, equals theta. So it's almost like the x is now here and the theta is there, but it's a different function. So it's taking the outputs and making them inputs. This one inputs an angle and spits out a ratio. This is an angle. This is a ratio, like a fraction, right? Like 3/5. This one takes the ratio and spits out an angle. So again, arctan or inverse tangent of that ratio is going to give you an angle. So what does that mean? Well, still we'll use cosine of theta equals 18/23. So we did adjacent over hypotenuse. Whoops. Now what we do is to basically flip this on its head. To undo this, we use arc cosine on both sides. So technically what we're doing is we're doing this on both sides. Okay, this is a little bit crude in how I'm doing this, but that's going to essentially cancel that out and give us arc cosine, or cosine to the -1, of 18/23. Now, I personally don't love this cosine to the -1, so I just want to make sure that you're aware that this is also called arc, A-R-C-C-O-S. Okay, this is arctan, A-R-C-T-A-N. Okay, it's not to the -1 power in any way. No connection whatsoever to that. Okay, because people always think it's the reciprocal. It's not. Okay, so it's the inverse of it. So to the -1 is a way that they'll kind of, if they say f of x, and then they were going to take the inverse of it, they would put it to the -1. So to the -1 sometimes means inverse, sometimes means it's to the power of -1. But on this screen, all these to the -1s that you're seeing are all because they're inverses. So all we need to do is take the cosine to the -1, which is the arc cosine or the inverse cosine of 18/23. So we'll use the second button, cosine, and we can do it on this little baby calculator too. Second cosine, and it was 18/23, parentheses, 38.5 degrees, 18 over 23, 38.5 degrees. Tiny bit different rounding, but otherwise good. So we just found that this was 38.5 degrees when rounded. Okay, so that's good. I think there's going to be more examples if I go on, so let's skip over 8 for now. Okay, yeah, perfect. A bunch more examples. And there's too much else to it. That's solving the triangle, so that's kind of like putting it all together. So some of these will be for you to practice. Let's look at this one. So this is going to be opposite over adjacent. Tangent of theta equals the opposite over the adjacent, and we have no hypotenuse. So what we need is to arctan this, but I'll write the notation. This is what your calculator will look like, and that will give us theta. So all we need to do is go and type that in. So second tangent, you see that tangent to the -1, that's arctan, or inverse tangent. We're putting a ratio in, and we're getting out an angle, 43,363. 43,363, and we're back to degrees, of course. I don't love that we're back to degrees, but it's sort of how it has to go for right now. So, okay, I don't want this to go on forever. I will probably ask you to try the rest of the problems on these 2 pages. Solving rectangle means find all side and angles, basically. So that's all it's saying. So it wants us to find BC, so that's this. It wants us to find AB, so that's this. And it wants us to find the measure of angle B, which is that. Okay. So measure of angle B, we don't even need trig for. We can just subtract because this is 90 and 72. So it's, it's 72 plus 90 plus angle B equals 180. So that's going to be angle B equals, I'm going to take my time and try to figure this out, 18 degrees. So that's 18 degrees. So this triangle had that going for it, but it might not have. And we'll talk about what we would do in that situation. Now we'll try to find the green side. So if I'm going to do the green side, I suppose I'll use 72. And I'll say cosine of 72. But of course I could have used sine of 18. That's what's interesting. And actually the reason that sine and cosine are related, like sine and then cosine, is because they're complementary. So in other words, cosine of 72 equals sine of 18. And sine of 30 equals cosine of 60. So basically, sine of any number, right? If you take that from 90, so kind of a crude way of looking at it, but right, and that kind of works both ways. So basically, they're complementary. So, anyways, that was just an aside. It's something that you should kind of think about. That's what that co is for. So sine is complementary to cosine. So cosine of 72 is going to be adjacent over hypotenuse. And so you'll have x equals, and I think about this like I've done this enough times to know that basically whenever you're in this situation, you're going to end up multiplying by x, and then you're going to end up dividing by this cosine of 72. So pretty much what's happening is these are switching places, right? So in other words, these just switch places. Okay, so 15 divided by cosine of 72. So 15, let's do alpha x. 15 divided by cosine of 72. 48.541. 48, whoops, this should be in green. 48.541. Okay, and then I'll just use the space above to do the last one. So I'll just kind of go into this area here. Okay, BC. So we could again use 72, or we could use the 18 degrees. Doesn't really matter. But if we use 72, it would be, I don't know, let's do O for opposite, and then adjacent, right? So tangent of 72 is opposite over adjacent. So 15 times tangent of 72 will get us that opposite, that BC. So 15 times tangent of 72. You can really just type that in, I think. Does a pretty good job of multiplying those. That's 46.165. Okay, so that's pretty good. I don't think that anything is too crazy. Let's look at the next triangle. You'll see that this one has an angle in it, so 14 will be fine. Now these ones don't have the angles in them, so what you'll need to do is, figure that this is, I don't know, theta, right? You'll have to say that tangent of theta, I guess, is equal to 22.5 over 21, and then you'll use inverse tangent to get theta. So it'll be 22.5 over 21. And that'll get you that angle. Then you can solve to find the others. You could use Pythagorean theorem, or you could use trig. I'd recommend trig over Pythagorean theorem since that's what we're pressing. But otherwise, we are in good shape. So please, as part of your notes, just finish up these ones. And there may be some more to do as well. But it should be pretty doable in the time you have, I hope. All right, I hopefully will be feeling better soon. And so if I'm missing you, sorry about that. And if you need anything, please reach out. I'll see you in the next video. Peace.